We are Team Vinci, and this is our assessment of the Clayco construction operation at 308 East Green Street. A team from Vinci studied the productivity of a crew of rodmen placing rebar caging for a second floor beam in order to make calculations and suggestions for improvement. We developed and adjusted crew balance charts and have come up with 3 proposals that will significantly increase productivity on the job site.
For this productivity improvement study, we observed the building at 308 Green Street. This will be a high-rise apartment building opening next fall. We were able to observe from the neighboring building at 309 Green Street, which offered a good vantage point for viewing and filming from a safe distance. After observation, we performed crew productivity analyses and proposals to increase productivity, all of which will be explained in more detail by the rest of our team.
We analyzed several of the construction methods used in this project. The first being site preparation. We looked at site safety and security. This project is located in a high pedestrian traffic area, so safety and security are of the highest concern. Fencing and scaffolding were set up to prevent cars and pedestrians from wandering onto the job site. The entire perimeter of the site is secured from intrusion. Next, we looked at the excavation. The project is being constructed on the site of a parking lot. Excavation was required to haul away old blacktop and create space for the partially underground automated parking system. Next, we looked at backfill and foundation work. Prior to this project, the location was home to a relatively light structure. Piles were driven to support the tower and excavated, and gravel was backfilled. Concrete methods. Concrete beams and columns in the project were brought in as pre-stressed, prefabricated components. A large crane was used to place these components as needed. The slab will be poured directly into place after the placing of proper steel reinforcement.
The cycle observed for this construction project was the tying of rebar for beam caging, and 6 workers and 1 construction saw were observed for the analysis of this cycle. Some of the challenges that we faced, or rather, some of the challenges that were faced were that workers were moving between different tasks on the construction site and were not present for the entire cycle duration. And this is represented in our crew balance chart as empty cells. And this was a challenge to us because it did not allow us to exactly know what those construction workers were doing when they were out of sight. Much opportunity for improvement exists in cutting down on idle time of the workers who are being unproductive, and also cutting down on workers moving between different tasks on the construction site. Here you can see the crew balance chart of our existing operation, which was taken from the 309 building where we had a good vantage point as aforementioned. Here you can see that white hat, the worker labeled white hat, has idle time, and as well as the worker titled suspenders. This is one great area Vinci sees as a great opportunity for improvement, is to cut down on this idle time. Here you can see a work breakdown of the required input for each task in this cycle. For instance, 1 minute and 30 seconds of man minutes were spent per 10 feet of laying the rebar caging. For the existing operation, the entire cycle for 10 feet of beam rebar caging was 35 man minutes for the 10 feet.
So here are some of our proposed improvements for that cycle time. The proposal number 1 improvement was to eliminate all the unnecessary idle time from the original crew balance chart by reassigning the affected workers to other projects at the job site. White Hat had a total idle time of 2.5 minutes, and Suspenders had an idle time of 7.5 minutes, for a total idle time of 10 minutes. White Hat was reassigned 1.5 minutes of prepping material and 1 minute of moving material, while Suspenders was reassigned to 0.5 minutes of moving material and 0.5 minutes of placing stirrups, with an additional 6 minutes of tying stirrups. The new cycle time for improvement 1 is 7 minutes, which is 4 minutes less than that of the original crew balance chart. The new required input is now 28 man-minutes per 10 feet, which is 10 man-minutes less than the required input of the original crew balance chart. This is a substantial improvement. As you can see here, this is the adjusted crew balance chart with the moving material and tying stirrups in place of the idle time originally seen in the original crew balance, and the work breakdown resulting in 28 man-minutes per 10 feet as compared to the original. Proposal 1 implications were that it requires White Hat to stay on activity for 2 minutes longer than in the original schedule. All workers stay on the activity for the entire cycle time. They will not be available to help with other activities. This plan assumes that all workers will be productive 100% of the time.
For Proposal 2, we take one worker from another activity on the job site to work on the activity of interest. This reduces the cycle time from 11 minutes to 6.5 minutes. And the required input was reduced by 9 man-minutes per 10 feet of rebar caging. The implementation of this proposal requires that communication with foreman and superintendent occurs in order to authorize a shift in labor allocation on the job site between activities. And by this point, we're just trying to highlight the fact that in order to have a worker taken from one activity in order to work on the activity that we studied, you need to make sure that the foreman and superintendent are aware of this and that they can make adjustments accordingly. Additional supervision is also required from the foreman in order to ensure that the added worker is staying productive. And Vinci would like to consult that it's important that just because you're adding more workers to a certain activity doesn't mean that the crew will necessarily be more productive. And then also, increased productivity leads to a decreased cost. Here you can see the crew balance for this proposal, and the main worker who was taken from another activity was the worker titled Vest. In the original crew balance, Vest was not on this activity until he arrived in order to do planning. And here you can see that he starts working on this activity at time 0 with moving material, and also helps with placing stirrups and then moving more material. Here you can see the work breakdown of Proposal 2, and the required input is 29 man-minutes per 10 feet, which is a 9 man-minute per 10 feet reduction. The implications of this plan is that it requires Vest to be taken from another activity on the construction site in order to work on the activity of interest. And this could have an adverse effect on the productivity of that other activity which Vest was taken from. More workers working on the activity of interest requires more supervision and management to ensure the crew is staying productive. And this plan also assumes workers will be productive 100% of the time.
The third proposed improvement is to eliminate all idle time from the original crew balance chart by reassigning the affected workers to other projects at the job site. White Hat had an idle time of 2.5 minutes, and Suspender had an idle time of 7.5 minutes, for a total idle time of 10 minutes. The new cycle time for the third proposed improvement is 11 minutes. While this cycle time is equal to that of the original crew balance chart, other projects will benefit from these additional workers, and the overall job site required input will increase. The new input is 27 man-minutes per 10 feet, which is 11 man-minutes per 10 feet less than the required input of the original crew balance chart, and is a substantial improvement. Here you can see in the crew balance that we utilize workers to work in all other areas, and there is 0 idle time. You can see in this work breakdown that each man only gets 1 minute for a water break, and the total cycle time is 27 man-minutes per 10 feet, which is a 12-minute increase from the original. This plan does not improve the cycle time at all. It simply makes the process more efficient by lowering the required input. This plan requires workers to leave the activity of interest sooner than the original schedule. This puts the burden of the supervisor on whoever is managing the other activities on the construction site.
In conclusion, what does all of this mean? Vinci is here to help you know how to choose the best plan. The factors of consideration in this project were cycle time, required input, effect on other activities on the construction site, and the subsequent ease of implementation. One must determine the most important factors to optimize when selecting an improvement plan. Improvement Plan 1 and 2 optimize cycle time and should therefore be selected if an activity is on the critical path. Improvement Plan 3, on the other hand, optimizes cost reduction and should therefore be selected if budget is the biggest concern for the given activity. Between Improvement Plan 1 and 2, Vinci sees that Plan 1 is better because it has a lower required input and has less of an impact on other activities. This, of course, is an exception to cases where there would be a high reward or penalty for a early or late completion time. Under a holistic approach, Vinci sees that Improvement Plan 3 is the best option. This selection is made under the assumption that the activity of tying rebar for beam caging is not on the critical path. And the reason we made this assumption was because a parallel activity that was occurring at the same time was laying rebar for the slab, which was a much more time-intensive activity. Improvement Plan 3 is favorable because it has the lowest required input of the 3 options, it has the smallest impact on other activities, and is the easiest to implement. With that, we thank you for your attention, and we hope that this will help you to choose the best option when making your productivity improvements. Thank you.